Okay, so now we have some examples of how to multiply polynomial functions. So first off, just a notation, you're going to see this f of x times g of x, so this symbol will tell you we're multiplying, but it's also the same thing if I say f times g of x. So know that these two mean the exact same thing, we're just multiplying two things together, and again, for us, we'll use the box method. So with that then, let's try some examples together here in this video. First, if I say f of x times g of x, okay, I know that I'm multiplying, so I'm going to look over to my box and look at f of x. So this is 2x. I'll copy that the exact same way. And it's going to be times, oops, sorry guys, times, so we'll put times g of x. And g of x here is going to be this minus 3x plus 5. So I'll just copy that the exact same way, minus 3x plus 5. So I'm multiplying here. So again, I can distribute this just the way we do normally, but just to get over the routine of the box method, I'm going to use that for you here in the video. So this is a monomial, one term, times a binomial, two terms. So it's a 1 by 2 box. So I'll make a 1 by 2 box like this. I can then just go ahead and organize my information as 2x here. And then every term gets a column here, so minus 3x, then plus 5. And I can multiply. So 2x times minus 3x, remember multiplying, everything multiplies and the exponents are going to change. So 2 times negative 3 is negative 6. And then x times x is a list of 2x's, so it's x squared. See, the exponent changed. Then 2x times 5 is simply 10x. And then once, in this case, because it's small, once this is complete, there aren't any like terms, so your answer is going to be what you see. It's minus 6x squared plus 10x. And that's your response. Let's look at example L. Just try a different one. So here it says g of x times k of x. So g times k. So again, I'll first look over here in my table and pull those out. So g is minus 3x plus 5. So minus 3x plus 5 times k of x, and k of x here is going to be 7x minus 6. I'll just copy that 7x minus 6 right there side by side. So notice how it's a little bit bigger than the example I. It's a binomial, two terms, times a binomial, two terms. So it's a 2 by 2 box. So I'll make a 2 by 2 box here. And again, every term will get a side here, so I'm going to put minus 3x plus 5 here on the rows. So I'll put minus 3x on this first row, and then plus 5 on the next. And here over the top, I'm going to replace 7x minus 6. So I'll put 7x on this column, minus 6 on this column. So 7x minus 6. And I can now multiply. So again, multiplying, everything multiplies, exponents change. So here 7 times negative 3 is negative 21. And then x times x is a list of two x's, so it's x squared. As I continue, minus 3x times minus 6, so a minus 3 times a minus 6 is going to be a plus 18, so it's plus 18, and there's still an x on that term, because there's an x here. To fill in this blank, it's going to be 5 times 7x. Well, 5 times 7x is 35x. And then to finish, to fill in this little box, it's going to be 5 times negative 6. 5 times negative 6 is negative 30. So once this box is complete, I know I've hit every single term that I need, and I'm going to scan for like terms. And again, if you look at the diagonals, it's common in this method that you have like terms here. So I can combine those. So I can say 35x plus 18x is going to be 53x. So I'll put that here, 53x. And guys, I'm being kind of messy here, so please, on your paper, leave space for M here to do work there as well, but I'm kind of spilling over in the video, so sorry about that. And then I still have this minus 21x squared and this minus 30 that don't have any like terms, so I'll just copy them the exact same way. Minus 21x squared and then minus 30. And once I'm here, notice how I have no more like terms, so I'm stuck. So that's my answer for example L.